Ever since Zig 015, I knew that when I grew up, I wanted to use Zig 016. And maybe 1.0 at some point too. But today we're talking about 016 because it's finally out, and I'm very, very excited. Hopefully you are as well. I've got the release notes pulled up here. We're just going to do a casual release notes video. We're going to walk through these together. I've skimmed through this already, so I have a rough idea. I'll point out the things that I think are important. We'll talk a little bit about them. And you might be shocked because if you are aware of the I/O interface changes that are kind of headlining this, there's quite a bit of other things that I think are pretty important as well. So let's get into it. Okay, I'm going to assume you're not new here, but if you are, Zig's a general-purpose programming language and toolchain for maintaining robust, optimal, reusable software. Totally agreed. I think that's a very fair assessment. It is essentially a competitor in a way. A complement might be a better term to the C programming language. So a modern take on C might be something you would think of. A programming language that works really well with C might be another take you might have on the language. Some information about the software foundation. You can and should, if you have the means, consider donating to the Zig Software Foundation. It's a nonprofit. The money goes to helping pay for hours for the core team members. So, and as mentioned here, it's the most straightforward way to accelerate the project along the roadmap to 1.0. Let's talk about this release though, because I am excited. So, like I mentioned, the I/O interface is really the headline of this release, but there are tons of other things that I think are important, and they mention that here. Don't sleep on the language changes or enhancements to the compiler, build system, linker, fuzzer, and toolchain. So let's talk about these. We have a giant table of contents. We could skim through this and find the things that are important, but I've got time, you've got time, we're all here, and we're happy to be talking about Zig together, so we're just going to go through this the old-fashioned way. So target support. So targets are the platforms that you can build out with Zig. So if you're writing a Zig program, being able to compile on those targets is generally important. The main thing here is that Zig CI is now testing quite a few new targets. So ARch64 FreeBSD, mostly BSD changes, some Linux support that we have here. PowerPC 64 Linux, exciting. But yeah, basically these are now being tested at the CI layer. So the Zig team is seeing failures much quicker, and hopefully we'll be able to react to those much quicker because they're more front of mind as a part of the CI process. We now have cross-compilation support for Mac Catalyst, whether you're Arch64 or x86. This was free, which is kind of cool, since the vendored lib system TBD that Zig ships with already provides the symbols for these targets anyways. We like things that are nice and free, so yeah. I guess one thing worth mentioning that if this is officially supported at this point, now it's something that the team officially supports as well. So while this was free, it's not completely free because there's, maintenance burden and overhead for supporting these that the team will have to deal with going forward. Initial support for long Arch 32 Linux. To be completely honest, I actually don't know what this is, but it's a flavor of Linux. I'm assuming 32-bit, and it has a long architecture, I would assume. Well, let's just search. We'll take this and just take a look. Yeah, so the Long Arch Linux represents a 32-bit variant of the Longson Long Arch CPU architecture being upstreamed into the Linux kernel. Okay, so specific instruction sets for this CPU architecture. That makes sense. Note that libc is not supported yet for this target, and LLVM still considers the ABI unstable, but programs using only syscalls via standard OS Linux can be built. So very, very minimal support at this point, but this will be continuing to grow as time goes on. Basic support added for Alpha, KVX, Microblaze, OpenRISC, PA-RISC, and Super H architectures. This is pretty cool. I'm excited for this one. For now, these targets require using either Zig's C backend with GCC or an external LLVM Clang fork. Okay. Support for Solaris, IBM's AIX, and ZOS has been removed. In general, the Zig project cannot support proprietary operating systems that make it unreasonably difficult to obtain system headers and thus audit contributions. Note that this does not affect Illumos. Being an open source fork of OpenSolaris, it remains supported. Yeah, I mean, that makes sense, right? Like, if they don't have access to the system headers and see contributions coming in, it could be difficult to actually figure out if those are being malicious or not. And it's yeah, this totally makes sense to me. It sometimes sucks seeing things being removed, but to be completely honest, I don't know of many people using these. Actually, I don't think I know of any people using these. So it kind of makes sense too. Stack tracing support has been significantly improved across the board. This is huge. Stack traces are so helpful at debugging your crashes. So almost all major targets now provide stack traces on crashes. Perfect. Various standard library bugs that mainly affected weakly ordered architectures and targets with unusual page sizes have been fixed. Great, love to see it. Improving reliability on Arch 64, Long Arch, and Power ISA. Compiler bugs, standard library bugs preventing Zig from working on big Indian hosts have been fixed. And then big Indian ARM targets have been fixed to emit BE8 object files when targeting ARM v6 rather than the legacy BE32 format. Some information on Zig's tiers. If you haven't, I'll skim through this because we've talked about it before, but essentially these are the tiers of supports for targets, and the goal is for tier 1 targets to have 0 disabled tests. This will become a requirement for post 1.0 Zig releases. But essentially, you know, with tier 1, you have all non-experimental language features that are known to work correctly, and the compiler can generate machine code for these targets without relying on the LLVM. Tier 2 is the standard library has abstractions that account for these targets. The targets have debug info capabilities and produce stack traces. libc is available for these targets when cross-compiling, and then continuous integration machines run the module tests for these targets on every push. So what you should be able to take away from these changes up here is that most things are in tier 2, and they've, you know, got plans for what will be fully tier 1 by hopefully 1.0. And that list may change too, but right now a lot of things are in the T2 period because continuous integration machines are running module tests for a bunch of new things now, natively on every push. So right there. There's some information about tier 3 and tier 4 if you're interested, but essentially executing machine code via LLVM, and the linker can produce object files. They're not considered experimental by LLVM, and then tier 4 is generating source code via LLVM. So anything kind of goes at the tier 4 layer as long as you can generate source code via LLVM. All that to say, you can take a look at this support table. I don't know how much sense it makes for us to go through it together, but you can kind of see the tier of support that they are offering. So x86 64 Linux is a tier 1. You can see, okay, self-hosted. I was very curious what the Lightning Bolt was. Thank you for the accessibility labels. But yeah, you can see here that it's tier 1, and all of these things are supported with full support. Several other tier 2s. Actually, I think everything else will be, not everything, but most of the things that we would expect would be tier 2. So like Arch 64, FreeBSD, Mac Catalyst, Mac OS, Windows, OpenBSD, x86 Linux, x86 Windows, x86 64 Mac OS. All of these are tier 2 at this point. So, you know, just kind of keep that in mind. I don't think you will have major issues with, you know, Linux, Mac, or Windows. Well, maybe Windows. But I will say that, like, for example, fuzzing did not come to Mac OS before it came to other platforms. So just, you know, things to be aware of when you are using a tier 2 or especially like a tier 3 or tier 4 supported target. Just be aware of that. OS version requirements. Yeah, feel free to read through this if that is something you particularly need to know. The short and sweet is like update your operating system at some point, and you should be good to go. All right, let's get into the language changes. This is the fun part. So I actually really like this. I read this at first and I was like, I don't really see the point. Like it's fine to support it, but I don't really know when I would use it. And then I started thinking about some code that I have with packed structs and specifically packed unions. And I'm like, okay, no, I do see when I would use this. So let's talk about it. Switch can now support packed struct and packed unions. You can use these as switch prongs. So if you don't know what that means, you'll have an example down here in just a second. But they are compared solely based on their backing integer, just like inequality comparisons. So in our case, we have a packed union. It's using a U2 to back the union. So we have A or B as our options. And you can see here that we have A. As an example, we're using that A right here, setting it equal to -1 because A is an I2 and B is a U2, but the packed union itself is backed by a U2. So since it's backed by this U2, we can switch on this, and it will be, the switch is essentially as if it was using all the permutations available for the U2 that are in this union. Hopefully that makes sense, but essentially you could unroll this into using all the valid numbers for U2s that are contained within this. So since we're backed by an unsigned 2-bit integer, we would have access to 0, 1, 2, and 3 for this packed union. In our case, we only have 2 values in the packed union, so we have 0 and 1 in this case. And when we switch on this, it would be essentially the same as switching on, well, this one's B, so this would be a 2, or sorry, a 1. If this was a 0 and this was a 1, this would be switching on U being a 1, and then everything else would go to unreachable. This example is a little interesting. It feels contrived, but if you have packed unions that you're working with or packed structs, you probably can start to see where this would be useful. Some other newly implemented features. Switch prong captures may no longer be discarded. Switch prongs may contain errors, which are not in the error set being switched on if these prongs contain comptime unreachable. So just be aware that your error set values for switches are changing. Union tag captures are now allowed for all prongs, not just the inline ones. Nice. And then decal literals, and I don't know the correct way to verb the to pronounce this. Kind of like SQL and SQL, and you know how people get split over that because it's intended to be. I guess it's an acronym, but the way it's written is not necessarily the way it's pronounced. I'll go with decals for this, but I'm not positive if that's the correct way to say that. But decal literals and everything else requiring a result type may now be used as switch prong items. So using enum from int. So nice. Essentially, like switch is a really nice structure, a control flow. If you aren't using switch, I would consider you to think about using it more, especially because now with Zig 0.15.1, we got access to labeled switch go-tos. I don't remember exactly what the... I did not like them. Yeah, okay, down here. Labeled switches. Sorry, it took me a minute to find those. I did not much care for these originally because I found them to be difficult to reason with the control flow of these switches. However, I have grown to like these quite a bit. And now the reason I'm calling this out, that we got labeled switches in 0.14, which I guess makes me think I've been writing Zig since 0.13, but I thought it was 0.14. The more we pack into options for the switch to switch off of in those prongs, the more powerful things like this become. So essentially, now that we have access to labeled switches, and we have in 0.15.1 and 0.16, we've added new functionality for switches. These are starting to become powerhouse statements for control flow. And I do think I would maybe caveat this by saying, as these become more flexible, they have the potential to become more complex. And I'm not saying you shouldn't use them. I really think you should. But I think just be mindful about how you're structuring things with your switches, because they are potentially getting into the spot where they could be quite unwieldy if you're not mindful about how you're structuring them. But I guess that's true about most things. Okay, what else? Bug fixes. A lot of issues with switching on one possible value types are now fixed. The rules around unreachable else prongs when switching on errors now apply to any switch on an error, not just to switch block error union, and are applied properly on the AST. Switching on void no longer requires an else prong unconditionally. Lazy values are properly resolved before any comparisons with prong items. This is actually, I just kind of skimmed through this. This is nice though, not needing to have an extra else if you are switching on void. Evaluation order between all kinds of switch statements is now the same whether you have a label or you do not. That makes a lot of sense, and I'm very happy to see that. Okay, equality comparisons on packed unions. This used to already be possible by wrapping the packed union into a packed struct. Now it's also possible without having to do that. Fair enough. The C import is moving to the build system. This is actually really big. So if you're, well, for people who are doing anything with C, which I have to imagine most people who are doing substantial Zig stuff are probably interoping with C in some way, shape, or form. So this is probably big for most people. So in the future, C translation is going to be handled via the build system rather than the C import language built in. I'm going to say that again because that's very big. In the future, the C translation feature will be handled via the build system rather than the C import language built in. So if you're using the C import language built in, eventually you will have to move, and it is now deprecated. So you could start moving now. So what does that look like? Okay, so here's your upgrade guide. So if you have all these C imports with C includes, like so, like including standard IO's header, the math header, the time header, the standard lib header, epoxy, GL header, and GLFW 3's header. So you'd have something like this, right? And then you might import like c.zig and expose C. You'll have your headers like so. So you might want to create a c.h file, which is what they're suggesting here. And in this header, you just import, or I should say include, use the correct terminology for the language, you include all of the headers that you want to include. So you essentially have a header that rolls up all of these other headers that you need. Then you can see down here in our build.zig, we can add a b.addTranslateC, point to our headers. So they have a root source file. You have your targets and your optimizes, just like almost everything else. And then that gives you an object that you can call link system library onto. So in our case, we're linking GLFW and epoxy for these two. And then we're adding our executable just like we would normally with any other Zig application, but we're taking that translate C piece and we are adding it via an import down here. So it's just like you would do your standard imports. I think what they're kind of going for here is essentially simplifying the way that you do imports, whether you're importing Zig or importing C. So you can see here you have imports. The name of that import is C. The module is that translate C.create module. So that comes back up here from the add translate C function on the build system. And then finally, at the end of the day, you just import it like this. Worth mentioning too, by doing this, the translated C code will be identical to how it was before with C import. That's nice. Having consistency in the way that things compile, like the binary output, is always nice to see, especially with a large change like this. I like this. Built-ins and memorizing built-ins is one of the hardest parts of Zig, in my opinion. There's so many built-ins, and I think we get some new ones in this release. Actually, I know for a fact we get a bunch of new ones. Yeah, simplifying this is nice. Like if there's just one way to import things, that seems wonderful. Yeah, here we go. Okay, here's all the built-ins. So this one's interesting. I like this. I got nervous seeing this because I'm like, wow, way more built-ins to remember. But the short and sweet is that if you are using @type, you now have individual specific type built-ins that you should be using instead. So for example, if you're using an enum literal, you have @enum literal. If you want to use an int, you have @int, and you can provide comptime values for how it's signed and bits as well if necessary. And that returns, that type. Tuples, same thing. So you have your comptime field types, and it returns the type. All of these will return a type for what it's worth because they are built-ins that generate a type for you. Pointers, functions, structs, unions, enums, etc. The short and sweet is that instead of using type like this, you will use the new type built-in. I like this. I feel like this is a little more obvious, and more specifically, if you have an LSP that is like ZLS, that is providing some level of autocomplete, when you type @ and you look for something to give you an enum, like so, and you type enum, nothing comes up in Zig 0.15.2. because there's not an enum, there's a type, and you have to know to use @type and then pass in enum literal as the option. This feels like it'll be more discoverable, so I'm here for it. I was a little nervous seeing a ton of more built-ins come in, but I think these are all very reasonable built-ins and are intentionally discoverable, which is great. I'm going to skim through these because they are the exact same thing, just different values every single time. So you can see, for example, type enumLiteral becomes @enumLiteral. Type int becomes int unsigned 10 for bits. Yeah, refer to this if you need to migrate or just want to learn more about this. They have some examples on how you would convert them. This one becomes particularly nice. Like, look at how simple this goes, as it is no longer a type annotation, and it is specifically just a tuple annotation. Like, that is so much cleaner. This is an important call out here that kind of snuck in to the tuple one, so I do want to call that out. To simplify the language, it's no longer possible to reify tuple types with comptime fields. So tuples are changing, and the fact that you cannot reify tuple types with comptime fields. Pointer, so you can see example here. This also becomes much cleaner. And I said I was going to skim through these, so let's skim through them. No float built in because there are only 5 runtime floating point types. This is functional. So this functionally is trivially implemented in userland. The function standard meta float can be used if creating float types if the bit count is required. There's no array built in because this functionally is trivial to implement with normal array syntax. A general array function would look like this. So you can see an example of what that might look like here. You have a function called array, it has a comptime length, a comptime element type, and a comptime sentinel, which is optional. And it returns a type. So then you just return here and you check if there is a sentinel, then you capture the sentinel in a group, and then you return an array with the length up to the sentinel with the element type, else you just return an array with the length and the element type. Pretty straightforward. There's no opaque. Instead, write opaque and then open a scope and close the scope. There's no optional built in. Instead, write question mark and then the type. There's no error union built in. Instead, write E exclamation mark T. There's no error set built in to simplify the language. It's also no longer possible to reify error sets. That's important to know as well. Instead, declare your error sets explicitly using the error syntax. Okay, allow small integer types to coerce to floats. If all possible values of an integer type can fit in a floating point type without rounding, the integer may coerce to the float without an explicit conversion. That's nice. I find that, so slight tangent. So if you haven't gone through my Space Invaders, building a Space Invaders clone in Zig tutorial, and I'm not saying you need to, one of the things that I intentionally wanted to do was make sure that people had opportunities to see type coercions. And because of that, I intentionally chose some slightly less optimal types than are necessary. So we would have to, coerce using as and things like float from int and other things of this nature. The reason I mention this is because holy crap, I did not expect to have so many explicit conversions. And at the end of it, I realized that we were doing explicit conversions like crazy. So I know that Zig's all about explicitness, but I was also just looking through the source code when we finished, and it felt like most of the noise in the code came from conversions. So I do kind of like the idea of allowing things to coerce without an explicit conversion. So you can see an example of that here, right? So in the past, we would have a U24, like 1, 2, 3, and then we would want to coerce that to a float. So we have a float 32, and we would say @float from int, and then you would pass in the int. Now what you can do is you can just assign the foo_int to something that is declared as an F32, and it will coerce on your behalf. However, there's caveats. If it is not a small integer type, so I guess U25 in our case would be a large integer type, it is essentially too big and you need to do an explicit conversion in that case. Oh, cool. This is part of a larger effort to improve ergonomics for making video games in Zig. Yeah, cool. I did not realize that, but I'd like to think that maybe I had some part in helping with that, but I don't think I did. Okay, forbid runtime vector indexes. So an upgrade guide. So you are iterating through a vector here. You're capturing the index into scope, and then you are iterating or indexing into that vector here. So instead, what you need to do is coerce the vector to an array. So you can see what that might look like here. So you get the vector type by using type info and passing in type of vector, and then getting the dot vector on that. And then you are able to create an array with the vector type's length. So it's going to give you, the vector type will give you the actual length that you need for that value. And then the child here, and then assigning the vector to that. And then from there, you can iterate through the array like so. This was changed as part of reworking the reworked bival syntax lowering. I actually have not read through this yet, so I'm not 100% sure what this entails, but that might be a fun thing to explore too. Vectors and arrays no longer support in-memory coercion, so if you were using pointer cast to convert between memory and vector memory, use coercion instead. If you were coercing from any error, an error union between any error and an array of I32 to any error in a vector of size 4 with type I32 or similar, you need to unwrap the error first. Okay. Yeah, I mean, I get that's fine. That seems reasonable. It is weird because essentially you are like the types have similar structure in the fact that like it is an error union in both cases, but yeah, it seems reasonable. I'm sure that this probably simplifies a lot on the language side, so small trade-off to make. Forbid trivial local access returned from functions. One thing that Zig beginners struggle with, particularly those unfamiliar with memory management, hey, that was me, is returning pointers to local variables from functions. This is challenging to address because it is legal to return an invalid pointer. That is very, very true. Man, so many times have I done this when I was first starting out. And I'm sure every now and again I will probably do it as well, for what it's worth. It's something that I think I've gotten better with. But so this is a perfectly valid function. The illegal operation only occurs if the returned pointer is dereferenced. Even then, it's legal to have a function that unconditionally invokes illegal behavior. So, for example, function bar, no return, unreachable. So this is basically the same thing from the language's perspective, or the compiler's perspective. So given this function, the expression bar is equivalent to the expression unreachable. So how then can we make it a compile error to return an invalid pointer from a function? It's semantic pedantry. We forbid all expressions that trivially, i.e. without type checking, lower to return undefined without the justification that the expression should instead be written canonically as return undefined. Okay. With the justification that the expression should instead be written canonically as return undefined. Okay, so if you're doing something that essentially at the end of the day would be return undefined, it needs to explicitly be written as return undefined. That makes sense to me. So here's an example. So you have a compile error now because what we're doing here is we have a function that returns a pointer to an I32. We declare a locally scoped I32 that will go out of scope on the stack once this function returns, and we return the address of this X, which is that I32. And our compiler error here is saying, hey, you have an error because you're returning the address of an expired local variable X. This is really nice. This might be, it's too early to tell, but as of right now, this is the forerunner for my favorite feature in 0.16. I think this will help with accessibility for the language, especially for people who don't have a good memory management background. And then I also think, a good memory management background, a strong background of manually managing memory. I also think that this is just something that occasionally happens, and if the compiler is able to unroll a bunch of complexity and at the end of the day say, hey, I know your function looks like it's doing all this crazy stuff, but you have this one weird prong that is doing something that could return the address of an expired local variable. Just if the compiler can help capture that and surface that, I think that's huge. More compiler errors of this nature are planned. Heck yeah. Tell me more. Make this a little bigger for you. Forbid local variable references returned from functions detectable by single pass AST analysis. Okay, so this is the one that we were just looking at. More information on that. They're semantically equivalent, sure. Yeah, I would maybe suggest reading through this if you're curious about this more. This is the first time I've seen this, so I feel like maybe I should have read this beforehand so I don't waste both your and my time skimming through it now. But I like the idea of this. I think compiler errors are fantastic, and I think if we can surface this type of stuff at compilation time, the language just becomes that much better. I would much rather be frustrated at compile time than frustrated at 2 in the morning because my system has blown up in production because of a weird edge case that I did not catch locally. I also think that maybe worth mentioning too, like Zig has an emphasis on software doing what it's intended to do, and I feel like this is like correct, right? Like this is making sure that the software is correct software. Unary float built in forward result types. Previously, Zig would not forward a result type through the following built-ins. So if you have these built-ins, this has now been changed, where previously you couldn't write square root float from int in, since square root would not forward the f64 result type from float from int. Now you can. This is part of a larger effort to make more ergonomic video games in Zig. A larger effort to improve ergonomics for making video games in Zig. Sorry, it's early and I've not had my coffee yet, so I'm going to take a break and have a sip. Okay, what else? Yeah, this seems nice. I like this. Being able to provide that type of information more implicitly, it's just nice. Like I definitely struggle with the balance between implicit and explicit. I like Zig's lean towards explicitness, but man, sometimes it just feels like I'm being so freaking explicit. And it does feel like it's not very ergonomic. So I'm happy to see this. Pretty excited for actually a couple of different things to help with making video games in Zig. That seems like a really good move. And to be honest, I don't know of any big video games in Zig. So it seems like the Zig team tends to really prioritize on real world Zig usage, like Tiger Beetle and Bun and things of that nature. But I don't know of any large video games in Zig that they're taking feedback from, so it's nice to see that they are considering this stuff. Floor, seal, round, trunk conversion to integers. Floor, seal, round, and trunk can now be used to convert a floating point value to an integer value. Heck yes! This also is a runner-up for one of my favorite features for 016. And we haven't even got to the good stuff yet, which is crazy. Yeah, this does exactly what it says on the can. So you can now use these to convert a floating point to an int. You don't have to manually convert it to an int. Int from float is now redundant with trunk and is therefore deprecated. Heck yeah. Again, ergonomics for making video games in Zig. Forbid unused bits in packed unions. There was not plainly one possible way of mapping packed union representations to bits. A desirable feature of other packed types, for example, enum u5 plainly represents 5 bits in an obvious manner and is allowed in packed contexts, but optional u8 has 2 reasonable ways of mapping to 9 bits and therefore it is not allowed in packed contexts. But optional u8 has 2 reasonable ways of mapping to 9 bits, and therefore... Okay, sure, that makes sense. This ambiguity is resolved by requiring all fields of a packed union to have the same bit size of as the backing integer type. Sure, that seems reasonable. I don't think I was doing this beforehand, but I do feel like this is something I could see someone trying to do. I'm actually curious if this is going to cause issues for people who have tried to do this. So here's an example, right? So you have a packed union, you have a U8 and a U16. Yeah, this is really interesting because if you run into an X, the size of this would be the U8, right? But if you run into a Y, the size of this would be a U16. So like, for example, going back to games just for some reason, let's say you have a camera and the coordinates that the camera are at are represented via a packed union. If your game engine you have a game engine, just to clarify, not a game. If your game engine supports 2D and 3D, you might find yourself in a really similar scenario here, where you have like a packed union and you have 2D, which is, it's 2 values worth of space, and you would have the X and Y. And then you would have like 3D, which has 3 values worth of space, which is the X, Y, and the Z. But now you're always going to be taking up the maximum amount of space with the packed union. Oh, okay, yeah. Oh, that makes sense. It feels weird. It, again, feels like more correct software. Like it's written in a way that if you read this, you understand exactly where the bits are going, which again is very, very Zig. So it makes sense that that is why they're making this approach. And you can see what that would look like down here. I was kind of skimming over this line, which actually is the most important line in this case, because if data is a U8, I still need another U8 worth of space somewhere in X. So you're essentially creating this padding that throws away that space, which feels a little bad, but at the same time, I'm sure there's quite a few optimizations you get from you always having the same size, regardless of which prong of the union is active at any point in time. So hopefully that makes sense. If it doesn't, let me know in the comments and I'll try to elaborate more on that. Forbid pointers in packed structs and unions. Fields of packed struct and packed union types are no longer permitted to be pointers, implementing proposal 24657. This actually makes sense to me. I don't know. I'm kind of curious why that was ever the case, but the primary reason for this change is that constant values containing non-byte aligned pointers cannot be represented in the vast majority of binary formats. That is very, very reasonable. Additionally, there are some targets on which pointers cannot be represented merely as their address bits and have additional metadata bits too. In this case, it does not make sense to pack pointers into an integer as packed types purport to do. Makes sense to me. If you are relying on pointers and packed types, you can instead use a usize field and convert to and from a pointer using pointer from int and int from pointer. Explicit backing integers on packed unions. So although previous versions of Zig allowed packed struct types to specify their backing integer type with the syntax packed struct, this was not previously permitted for packed union types. In Zig 0.16.0, this has now been allowed. Okay. Sure. Although previous versions of Zig allowed packed struct types to specify their backing integer type with syntax packed struct t, this was not previously permitted for packed unions. This has now been allowed. Okay, yeah, we've seen like, sorry, I was so confused. This is interesting that this is so far down in the page because we've seen so many examples of this already. But yeah, essentially you can specify the backing type for packed unions. Cool, makes sense to me. Using that @union built-in that we just talked about that was introduced in this version as well. You can see what that looks like here. Forbid enum and packed types with implicit backing types in extern context. So essentially you can't do implicit backing types with externs, which that seems reasonable to me. I don't think I have enough experience with doing that or externing really much in general. I feel like Zig is mostly the end of my language pipeline, and I'm not really externing stuff to be used. But then it makes sense that you wouldn't want to be able to extern the implicit backed types for packed structs and unions. Maybe I should talk about why. This breaking change was made to avoid the ABI of a type being determined entirely implicitly based solely on its fields. In particular, this matters because U8 and I8 may have differing ABIs in some contexts, and it is not clear which is being used if the choice is implicit. Yeah. Okay, that is along the lines of what I was thinking. But again, I just don't know if I've ever found myself in this type of scenario with externing these. So if you are doing this, here's an example of what that might look like. Here's an example of the error that you might see. Unable to export type, extern implicit backing type enum. Note integer tag type of enum is inferred. Note consider explicitly specifying the integer tag type. Enum declared here. Yeah, okay, so if you are externing enums or pack types, you gotta give them an explicit backing type. All right, lazy field analysis. A problem we noted since introducing IOs and interfaces is that if a type is used as a namespace, its fields will be analyzed away. For instance, using standard IO writer in any way pulls in the vtable of standard IO. Some cases of this could even result in unnecessary code gen, which can bloat binaries. Now, struct, reminder that files are structs. Yeah, easy to forget that. Union, enum, and opaque are only resolved when its size or the type of one of its fields is required. This means that not only can you use types as namespaces without referencing them, but you can even use them in non-dereferenced pointers. You can even use non-dereferenced pointers like *t without needing t to be resolved. This was changed as part of the reworked type resolution. So essentially, you can only use types as namespaces without referencing them. But you can now use non-dereferenced pointers without needing the type behind the pointer to be resolved. Okay, that seems reasonable. Okay, now the struct enum, union, and opaque are only resolved when its size or the type of one of its fields is required. So essentially, this is just becoming much lazier, and hopefully with the benefit of us not analyzing away types. Or pulling in the entire vtable of standard IO, for example, bloating codegen. They have a couple cases up here that they've mentioned. There's more information on the reworked type resolution piece in the release notes, which I guess we'll get to here in a minute. Pointers to comptime only types are no longer comptime only. For instance, though comptime int is a comptime only type, a pointer to a comptime int is not, and neither is an array of comptime int. This may seem confusing at first. The easiest way to understand it is to consider function pointers. So if you have a pointer to a function, is a runtime type. However, you are not allowed to dereference it at runtime because the element type, the function body type, function void, is comptime only. So these pointers can exist at runtime, but may only be dereferenced at compile time. This makes them more or less useless at runtime, but there's actually an exception to that. Suppose you have a slice of const standard built-in type struct field, and you want to pass the name of each field to runtime code somehow. Previously, you would have done this by constructing a separate const u8. And however, now you can pass the the array of const standard built-in type struct field directly to a runtime function. Naturally, this function cannot load a struct field from a slice at runtime. However, what it can do is load the name field because it has a runtime type. Okay, really interesting tangent on how this can work in a really interesting, useful scenario. But essentially here, if you are wanting to have the name of functions and have those available at runtime, you could follow something like that. But I think the bigger takeaway here is that pointers to comptime only types are no longer comptime only. Also a part of reworked type resolution. Explicitly aligned pointer types now distinct from naturally aligned pointer types. So, okay, that makes sense, I suppose. So essentially, if you provide alignment, you get a different type of pointer than if you did not provide alignment. That seems very reasonable. Simplified dependency loop rules. There are new cases which are now dependency loops, which were now previously not. However, it is now more obvious why a dependency loop exists due to simplified type checking rules and enhanced compile time errors. This is huge. This also reduces the difficulty of formally specifying the Zig language. Also huge. Change of rework type resolution. I wish they had some examples for this, to be honest, but I'm happy that they're making headway on this. Again, this type of stuff, this type of stuff makes the language feel more accessible, in my opinion. And I know some people, like let's compare to Rust for just a second. I know some people, and myself included, when I first started writing Rust, got really frustrated with the borrow checker and the compiler constantly complaining to me about things not working. And I, at the time, had mostly a front-end background. So what I was used to doing was I would write some code and then I would type check it with TypeScript. And if I had some issues and I wasn't sure it was the right way to approach things, I would just as any and then get it visual on the screen and be like, does this feel right? And if it was right, then I would go back and fix the as any's and the turning off the linting and stuff like that and get it working in a nice, clean way. So I had this ability to kind of circumvent the compiler in TypeScript and just see something and see it on the screen and make sure it was working. And maybe that helped with my motivation after a long day of coding. Maybe it helped me actually make sure that I was on the right path. I don't know. But that felt nice. And in Rust, I was constantly not able to do that because it felt like every time I changed something, I had the borrow checker complaining at me. And I was learning Rust and very, very new to systems programming in general. And doing all sorts of really weird stuff that you shouldn't be able to do, like trying to declare something in a function and then return a pointer to that value, as we've talked about already in this video, that Zig no longer lets you do that too, which is Nice. But yeah, the point there being, like, I did not like the compiler for the longest time because it felt way too nitpicky, and I just wanted to see something. Like, let my program run to the point where it would crash so I could just see some progress. Because if you constantly are going back and forth with compiler errors, sometimes it feels like you're not making progress. Or at least it did to me. I've definitely grown as an engineer, and my patience has grown as a human since then. And I think I value that type of stuff way more up front. I also know, like, I trust the compilers now. So if the compilers are throwing errors and I'm like slowly whittling down the amount of errors that I'm getting from compilation, I know I'm making progress. Yeah, I guess the point that I'm getting at there is I feel like having a compiler creates a lot of safety. Having a compiler does create a lot of safety, but having Zig's compiler be even better at this type of stuff provides extra safety. And if it can guide users onto what went wrong and why, it's really, really nice. It helps people learn the language. It helps people learn why the thing that they did doesn't work. And it helps make sure that they are catching this stuff before it becomes a problem for their users, because the compiler won't let them. Okay. 0-bit tuple fields no longer implicitly comp time. So back in 0.14.0, over a year and a half ago, I think, a rule was unintentionally introduced that tuple fields with 0-bit types are implicitly promoted to comp time fields. Unintentionally introduced. Interesting. So we have comp time here, const s. We have a struct void. Okay, I can see why this would be introduced, even if unintentional. So essentially, this struct is taking up no space, right? And you can see here, compile time log, we're checking that it is comp time, and here's what we're getting back. So a Boolean that is true. Zig 0.16.0 reverts this change. The above tuple field is no longer considered a comp time field. However, this does not prevent the field value from always being comp time known. So for example, we have a struct, and we check to see the value of that struct. Runtime known is undefined, and then we set it right here. And then even though the tuple is runtime known, the 0-bit field is comp time known. So we can check that runtime known is equal to this. Yeah, okay, cool. This makes sense to me, and it's a comp time assert, because essentially we know that the type here needs to be void in this case, so this doesn't get like erased out. In other words, this change is almost entirely non-breaking. The only case where this could affect old code is if you were directly relying on standard built-in struct field name is comp time from type info, or the equivalence of tuples with or without explicitly declared comp time fields. These tests both pass in Zig 0.15x, but fail in Zig 0.16x. I don't think many people are doing this. I'm going to skim through this test, but feel free to read that if that is relevant to your interests. Okay, standard library changes. Let me have a sip of coffee and then we'll get into these. All right. Standard library added io.dir rename preserve. So rename operation without replacing the destination file. That's nice. Socket create pair. So being able to create pairs from sockets. Remove segmented list, meta decal list, or declaration list. I feel like I should just say declaration instead of decal, but whatever. IO generic writer, IO any writer, IO null writer, IO counting writer. Notice the capital I too, that'll become relevant here in a minute. Thread mutex recursive. So I've actually not used this, I don't think, but I would assume this is a mutex that has some recursive awareness if you were doing recursive functions to make sure that you're not locking yourself out from recursing on it. I'm not entirely sure, but that's interesting. There are some error set changes. So several of these become cross-device. So rename across mount points becomes error cross-device. Not same file system becomes error cross-device. Sharing violation becomes file busy. Environment variable not found becomes environment variable missing. Looks like this one's just standardization probably. These are interesting. These feel like they tell me different things. So I don't know. I would probably want to actually see where these are used and then see how the values are surfaced now. But to be honest, I don't think I've ever ran into this one, or this one. So maybe it won't affect me too much. Standard ArenaAllocator rename returns error dir not empty rather than path already exists. I have run into this one. Okay, cool. Yeah, so if you're, I guess that's fair. Dir not empty is fine. This is also fine too. I feel like this is maybe more correct. But this was something that when I found this and ran into it, I was like, oh, okay, cool. I'm trying to rename something, but something already exists at that path. And then in this case, checking that, I guess the output dir is not empty is the new error message. Actually, I'm starting to have questions about this, but I'll look into this and see exactly why that was changed. Some uncategorized changes. I don't know how to read these. Oh, okay. In regards to fumped, formatter is moved to alt. Format is moved to standard IO writer print. Format options is just now options. Buff print Z is buff print sentinel. Compress have been updated to IO reader and IO writer. Dynlib, dynamic lib, removed Windows support. Now users must use load library exw and get proc address directly, which is probably what they were already doing anyways. Math sign returns the smallest integer type that fits possible values. Trigger automatic fetching of root certificates on Windows. Tar extract, sanitize path traversal, bitset, enum set, replace init empty, init full with declaration literals. Yeah, I'm just going to say the declaration. All right, the big stuff. I/O is an interface. Starting with Zig 0.16.0, all input and output functionality requires being passed an I/O instance. Generally, anything that potentially blocks control flow or introduces non-determinism is grounds for being owned by an I/O interface. What does this mean? So if you're blocking control flow, like a really good example might be if you were doing file reads, file writes, network requests, anything that is essentially you're blocking, right? Like you have a blocking operation. Or introduces non-determinism. This one's a little more interesting. I guess the idea here is when you take these non-blocking operations, a lot of times the output is non-deterministic. So for example, if you're trying to read a file, you might run into scenarios where like a file does exist, we start to read it and the file is removed during us reading it, or I don't know, I'm trying to come up with a really good example of the non-determinism, but I think that makes sense too. Along with the interface, this release comes with the following implementations. We have IO threaded, which is based on threads. With this implementation, IO operations are straightforward. Okay, sorry, the way that this dives into it, I feel like we're missing a lot. This feels like it's written as if you know about the IO changes that are coming in, and this does not tell me enough to feel confident telling you about it. So what we're getting is essentially a new IO interface, and when you define a function that does something that needs to run like in a way that blocks control flow. Or maybe it is well written because I feel like I'm just saying the exact same stuff that they have here. But you have a function that needs to block control flow. Like maybe you're doing network requests, maybe you're doing file reading, maybe you're doing something else. Maybe you're calling another function that does that thing, and you are essentially just trying to make sure that you are able to indicate that, hey, this function calls a function that blocks. You have options now. So this is essentially Zig's async await for modern day. So what you have here is these new IO packages that meet an interface, and the IO packages ship with the standard library. Why have an interface? Why do this? Why take this approach? The short and sweet is that Zig aims to be an extremely multi-platform language, and these implementations that Zig ships with out of the box are probably good for most cases. But as time goes on, we may find new patterns for building asynchronous operations into a language. And two things. One, some operating systems may end up supporting things that other operating systems can't, and people can build their own package that meets this IO interface and allows people on that operating system to use that one instead. The other option is we aren't beholden to the Zig team to implement these new IO interfaces. So if a new pattern comes out called quantum async or something, and it leverages offloading operations to a quantum computer or something really wild, because why not? We don't have to wait for Andrew Kelly to get access to a quantum computer and actually test this and build it out in a way that meets the Zig quality expectations. So instead, the community can just build this. We can build it up against a spec and feel confident enough that we publish a package that does what we think it does, especially what we think with regards to quantum. But the whole point here being that we have an interface, and we have some implementations of the interface that come out in Zig 016, and we can build our own on top of this interface. The idea here is that you write functions that will take in this interface, and as long as you're taking in this interface, people can choose what implementation you are using. So I write a package and I say I take in an IO interface because I've written a client for Reddit. That's a bad example because I don't think they let you do that anymore, but just bear with me. So I've written a client for Reddit in Zig, and you pass my library an IO interface, something that implements an IO interface, because I take in an IO interface. The nice thing here is that if you want to do a threaded implementation, you just pass in the IO threaded. If you want to do evented, you pass in IO evented. If you want to pass in, I was hoping to see more of these, to be honest with you, but I do not. But something that is green thread related, you pass in green threads. Actually, evented might be green threads. Yeah, it is. Different implementations, you can pass in different implementations. So maybe another example is you build your own. I write my client library, and you want to use it in a WebAssembly context, but I didn't build it with WebAssembly in mind. And the main issue that would probably cause you issues in WebAssembly would be how I do my IO implementation. But I just take in an interface. So if you build a WebAssembly friendly IO implementation, then you're good to go, right? You just pass in your implementation to my library when you call it, and I use your WebAssembly friendly implementation instead of like trying to spin up threads to do this or something of that nature. Okay, hopefully that's clear. Let's talk about what we get. So we have a threaded implementation. With this implementation, IO operations are really straightforward. For example, file system operations directly call read, write, open, close, etc. When updating code from Zig 015x, use this implementation to provide the equivalent behavior. It's feature complete and well tested, including cancellation. That's nice. This implementation is currently chosen by Juicy Main. We'll get to Juicy Main in a minute. I've also got a video on it if you'd like to learn more, because we'll probably skim through it, but it's important to know. So some options: no single threaded. So you could pass this in. Single threaded does not support task level concurrency or cancellation, and no single threaded does support task level concurrency or cancellation. The other IO package that we're getting out of the box, I guess there's two technically, is, IO evented. This one's a work in progress. This one's the one that I'm more excited about, to be honest. So this is serving to inform the evolution of the interface. Interesting. Based on user space stack switching with work stealing, known as M-to-N threading, green threads, or stackful coroutines. Yeah, both these are things that I should be excited about, and hopefully you are too. IO uring, although it was not the focus of this release cycle, there's already proof of concept implementing based on Linux's excellent IO uring API. This backend has really nice properties, but it's not finished yet. It's lacking networking, error handling, test coverage, minimal task stack allocations. IO KQ, this is proof of concept only, enough to fix a common bug in other async runtimes. And then dispatch is based on Grand Central Dispatch for Mac OS. The final one that we have in this package, I'm supposing, is failing, which simulates a system supporting no operations. So if you want to do some testing, maybe this could be a case where you would pass in failing. What's on the IO? So you have access to features, which are a task level abstraction based on functions, allow introducing operational independence, asynchrony, among any set of function calls. You have a group, which efficiently manages many independent tasks. They support awaiting and canceling all tasks in the group together. You have a queue, which takes in a type, and it's a mini producer, mini consumer, thread safe, runtime configurable buffer size. I actually didn't know we were getting this, and I'm actually pretty excited about that. That sounds like that'll be quite enjoyable to use. When the buffer's empty, consumers suspend and are resumed by producers. When the buffer's full, producers suspend and are resumed by consumers. Do you know what this sounds like? I'll tell you what it sounds like. It sounds like Go channels. And sorry for using the UI to make text bigger. I'm on a new keyboard, and I have my hotkeys memorized for Mac really well since I work on a Mac laptop. But on Linux, I don't actually remember how to get to the layer that I need to get to have access to Control and Plus on the same screen. So sorry. Anyways, Go channels. So yeah, channels are this typed conduit through which you can send and receive values with the channel operator. So I don't think we'll have the nice ergonomics that Go has because everything will be bundled onto the I/O interface. But yeah, essentially the idea here is very, very similar to Go channels. So you have sends and receives that block until the other side is ready. You have a size for the channel. And hopefully that sounds very, very similar to this queue. Select executes tasks together, providing a mechanism to wait until one or more tasks complete. This is similar to batch, which we'll get to in a second, but operates at the higher level task abstraction layer rather than the lower level operation abstraction layer. Batch is a lower level abstraction based on introducing independence among any set of operations. So you can batch stuff together. You can select something. So for example, you might want to maybe you want to see, you write some code that reads multiple files and you execute these all via a select and they execute together. And maybe you only want to wait until one completes. So you're essentially creating like a race. And that race is like which thread finishes reading the file that's assigned to it faster or something of that nature. So you could use select for that, where batch might be, I need to write 30 files with all different values, and I don't really care what order they operate in, and just like have at it. Clock, duration, timestamp, and timeout. Type safety for units of measurement. That's nice to see. So let's get into it. So there's a demo of making an HTTP request to a domain right here. And this will hopefully be, actually there's so much new stuff going on here. So this is Juicy Main, just as a spoiler. So we'll get to that in a minute. But the short and sweet is we have a GPA, we have an IO implementation. If we scroll up here, you can see that Juicy Main is choosing threaded. So we have a threaded implementation by default. We're getting some args. We have a host name that is passed in from our args. We create an HTTP client. We have to pass it an allocator and an IO implementation. You can see that we're also just using the values that are provided from Juicy Main. And then we, defer deinitializing that because that's a nice thing to do. It's intelligent to do, cleaning up after ourselves. And then we do our request. So we try HTTP client request. We're making a head request. We give it a scheme of HTTP, a host, a port, a path, and then defer deinitializing that. We send it without a body. We have a redirect buffer, and we receive the head response back from the server into the redirect buffer, and then you can see we log that information right here. So you can see that we have something like this when we actually run it. And this is taking advantage of the new standard IO interface. So this code has the following properties. It asynchronously sends out DNS queries to each configured name server. As each response comes in, it immediately asynchronously tries to TCP connect to the returned IP address. Upon the first successful TCP connection, all other in-flight connection attempts are canceled, including DNS queries. The code also works when compiled with f-single-threaded, even though the operations happen sequentially. On Windows, this all happens without WS232 DLL dependency. I would assume that's a big deal. I don't do any Windows development, so I'm not sure, but I'm assuming WS2 is a WebSocket dependency, but I'm not positive on that. Yeah, they mentioned that standard process init is thanks to Juicy Main. When upgrading code, if you find yourself without access to an IO instance, you can get one like this. So you can do .init single-threaded if you have an IO threaded struct right here. And then if you want that IO, you can call threaded.io. This works as long as you don't need task level concurrency. However, it's a non-ideal workaround, like reaching for a standard heap page allocator when you need an allocator and do not have one. Instead, it is better to accept an IO parameter if you need one, or store one on a context struct for convenience. Point is that the application's main function should generally be responsible for constructing the IO instance used throughout. I'm also just going to go ahead and throw out that if you're not doing this with allocators, you probably should be doing this with allocators too. If it makes sense to like create a general allocator and then maybe wrap it in an arena somewhere else so you can easily clean up the stuff that you allocate in that scope, that's very reasonable. But I guess just from experience, if you're not creating your allocator in your main function, or in our case, getting one for free from Juicy Main, you probably should be doing that. When testing, it's recommended to use standard testing IO, much like standard testing allocator. Okay. Futures. Futures are task level abstractions based on functions. IO async creates a future T, where T is the return type of the callee. Async expresses asynchrony, that the function call is independent from other logic. That's important. Async expresses asynchrony, that the function call is independent from other logic. Creating such a task is therefore infallible and portable across limited IO implementations, including those which lack a concurrency mechanism. Concurrency and asynchrony are not the same thing. It is legal for IO implementations to implement async calls by simply directly calling the function before returning. IO concurrent is the same as IO async, except communicates that the operation must be done concurrently for correctness. This necessarily requires memory allocation because that is the nature of doing things simultaneously. This function can therefore fail with error concurrency unavailable. In both cases, a future of type T is created. The struct has two methods, await and cancel. Await logically blocks control flow until the task completes, returning the return value of a function. So this is, everything works great, it does exactly what it's supposed to, nothing went wrong. The other option is cancel. So this is the equivalent to await, except also requests the IO implementation to interrupt the operation and return error canceled. Most IO operations now have error canceled in their error sets. So use this pattern to avoid resource leaks and handle cancellation gracefully. So we have a future here called foo, and it's an IO async. And then we defer if foo future.cancel IO, then we scope the resource, and then we say resource.dinit else, and then just it's an empty else. We have a bar future, which is IO async bar, and we do the exact same thing. We have defer if bar future cancel, we pass in our IO implementation, we scope our resource, and we deinitialize the resource, else empty else block. And then you can see here, we're trying foo future.await, we're passing in our IO implementation. Same with bar future.await, passing in our IO implementation. If the foo or bar function does not return a resource that must be freed, then the if can be simplified to, and you can just see here that it is essentially calling foo.cancel and then assigning that to a discarded value. If the function returns void, then the discard can also be removed. The cancel is necessary, however, because it releases the async task resource when errors, including error canceled, are returned. So important to do. I read this twice because if you aren't doing this, you're probably going to run into resource leaks. It would be nice if there was a simpler way to do this, or if it could somehow be automatically handled for us, or I don't know. That doesn't seem very Zig, to be honest, because there might be a time where you want to do something different. But the point being that like this is probably going to become kind of boilerplatey. So read through that, make sure you understand it, and make sure that you're doing this so you're avoiding resource leaks and actually handling your cancellations properly. Okay, so let's talk about groups. Groups are appropriate when many tasks share the same lifetime. They offer an O of 1 overhead for spawning n number of tasks. That's a really good sign. So, okay, we have a random IO source. We're passing in our IO, and we're getting an RNG interface. So we're getting some RNG. We're getting a uint less than 1000, and it needs to be a U16. Okay. We have an atomic value, we're initializing it here, and then we spawn a task for each element that sleeps a number of milliseconds equal to the element value, then adds that element. So we have a group, we call a init on it, we defer canceling that group, and then we call group.async, and we append via a sleep. You can see down here what sleep append actually does. So we sleep a certain number of milliseconds, and then call awake, I guess, or maybe this is an enum. Yeah, this is, I guess, an enum value. Not entirely sure. Maybe they have, no, they don't have more information on that. Okay. But yeah, so we essentially use the group, and then we await the entire group, and then we are looking at the value of sorted up here and ensuring that the result is sorted. I wish I had a little bit more information on like what is going on here. Cancellation low, lest one learn a lone reason. It's like they don't want me to be able to speak correctly in these videos. Low, lest one learn a lone release lesson, let proclaim cancellation should seriously be only be spelt thusly with a single L. Let not evil, godless liars lead afoul. That's my Shakespeare for the year. In the same vein as breaking out of a loop early, once you start doing multiple tasks concurrently with one L, you start running into situations where one task having completed, for example, by failing, means that you would like to interrupt other ongoing tasks, since their results and or side effects are already known not to matter, perhaps even not required, or perhaps even require being reversed. Yeah, so this would be like that example I mentioned previously of like racing to do something. So maybe you are trying to, you query like 10 different news APIs for a keyword, and you really only need one article to come back. So you query them all, and maybe you're like a news aggregate site, and you really want to make sure that you get breaking news immediately. So someone comes to your site and they type in something. I feel like I can't say anything without risking getting demonetized because of how weird the world's in the state right now. But they type in panda. And maybe you don't have anything on pandas, so you start by looking in your local database. You kick off a job that looks in your local database. You kick off a job that looks at your cache. You kick off a job that goes to CNN. You kick off a job that goes to NBC. You kick off a job that goes to whatever other news outlets you might want to check. And essentially, the first thing that comes back, I can cancel everything else because I don't care. I'm just trying to get the user something about this panda that they're searching for. So that would be an approach where you might do cancellation, for example. Another where things are being reversed starts to get a little trickier, but like if these operations aren't idempotent, and instead you have to do things like maybe you create a bot that's, I feel like this is malicious, but maybe you create a bot that signs up for several different services, and they're all email sending services, and you really just only want one that works. So you kind of give the bot this task and it goes and does these things. And if you need to clean up after yourself, like reverse, like let's say you find you successfully set up resend and you're like halfway through setting up the others, and you get a test email and you're done with everything else. You can cancel the other tasks, and you need to reverse what you've done. Like you might want to go in and close out your account from SendGrid or Mailgun or whatever. So that would be an example of when you might want to do like reversing. It's a bit contrived. I can't think of a better example off the top of my head. But file writing maybe would be another example where if you cancel in the middle of a write where you're streaming, you probably don't want to leave a half-streamed file out there, so you might want to clean up after yourself. Future group and batch APIs all support request cancellation. When cancellation is requested, the request may or may not be acknowledged. Acknowledged cancellation requests cause I/O operations to return error canceled. Even I/O threaded supports cancellation by sending a signal to the thread, causing blocking syscalls to return enter. So error interrupt. And responding to that error code by checking for a cancellation request before retrying the syscall. Only the logic that made the cancellation request can soundly ignore an error canceled. Otherwise, there are 3 ways to handle it. The most common is propagate it. After receiving it, call IO recancel, and then don't propagate it. This rearms the cancellation request so that the next check will have a chance to detect and acknowledge the request. Or make it unreachable with IO swap cancel protection. In general, cancellation is equivalent to awaiting aside from the request to cancel. This means that you can still receive the return value from the tasks, which may in fact have completed successfully despite the request. A good example for this is you make a network request to get some data, you do a bunch of other tasks, and then you call cancel. that network request may have already finished at this point, and it may already have data. So even though you're canceling, you're saying, hey, cancel this task. It's done, man. There's nothing to cancel. Like we've done the thing that you've asked, and I've got the data. So in this case, the side effects such as resource allocation should be accounted for. They have an example of opening a file and then immediately canceling. Note that we must account for the possibility that the file succeeds in being opened. So they have a demo here. We have an IO async. We're calling open file on the current working directory. We pass in IO, and then we pass in hello text. And then we defer if canceling. We have our file, and then we need to close. Else, we have an empty block. Typically, since both await and cancel are idempotent, the most useful pattern is to defer a cancellation after creating a task. This ensures the resource, including the concurrent tasks, are deallocated before returning from the function. Generally, Zig programmers don't need to explicitly add code to support cancellation because error canceled is baked into the error sets of all the cancelable IO operations. That's nice. However, one can add additional cancellation points by calling IO check cancel. It is rarely necessary to call this function. The primary use case is in long-running CPU-bound tasks, which may need to respond to cancellation before completing. Good to know. So you can think of batch as a low-level concurrency mechanism, which provides concurrency at an operation layer, which is efficient and portable, but more difficult to abstract around, particularly if you need to run some logic in between operations. Eventually, most of the file system and networking functionality are expected to migrate to become based on an operation, making them eligible to be used with batch and eligible to be used with operation timeout, which provides a general way to add a timeout to any IO operation. They have a list of what is currently available: file read streaming, file write streaming, device IO control, and net receive. Future is the equivalent, but at a function abstraction layer, which is flexible and ergonomic, but it allocates task memory and error concurrency unavailable when using concurrent, or unwanted blocking operations when using async can occur in more circumstances than the lower level batch APIs. So generally, here's the key takeaway from all of this. If you're trying to write optimal reusable software, batch is the way to go if you simply need to do several operations at once. Otherwise, you can always use the future APIs if that would essentially require you to reinvent futures. Or you can start with future APIs, then optimize by reworking some stuff to use batch later if reducing task overhead is desirable. We have some new sync primitives. This is actually going on way longer than I expected, but it is a really big release. So I'm going to speed up just a little bit until we get to certain parts, but you definitely read through these as well. So essentially, this API is integrating properly with cancellation. We have threads become IO events, wait groups become groups, futex, futex. I don't know what the F stands for. I feel like I should, and I'm blanking on it, but it just gets moved to a new package. Same with mutex. Conditions get moved to the IO package. Semaphore gets moved to the IO package. Read, write, lock to the IO package. Standard once has been removed. Avoid global variables or hand roll the logic yourself. We have some crypto upgrades around entropy. So standard crypto random bytes has been changed. So it's io.random now, and it takes in an you need to provide an IO instance for this. So you'll get like a threaded IO and call random. Standard crypto random now becomes standard random IO source. Again, you pass in that IO instance that you have, and then you get an access to the RNG implementation by calling interface. Some POSIX get random, very similar translations. We have standard options crypto always get random, and standard options crypto fork safety. Rather than these being standard wide operations, they're two different standard IO APIs. So there's some changes to cryptography there, some changes to clock resolution and time that we have here. So standard time instant becomes standard IO timestamp, standard time timer becomes standard IO timestamp, standard time timestamp becomes standard IO timestamp now. All of the file APIs have been migrated to IO, so it's a lot of breaking changes, but unlike WriterGate, this change set is expected to be generally easy for Zig programmers to manage because it does not require much critical thinking. What are they trying to say? They're trying to say we can't do critical thinking? For example, typical upgrade path will look something like this. File.close becomes file.close with an IO that gets passed to it. Although your upgrade diff might be large, it should be quite simple to understand what needs to be done. Some things that have been added, some things that have been removed with no replacement. There's quite a lot. So a lot of the dir stuff, renames, deletes, that type of stuff. Some changes. copying files, making directories, deleting files. All of this goes into the IO implementation. Some of these go into processes, actually. That's actually a really good point. So getting like self-exe path, standard process executable path. Your eyes would glaze over if I just walk through all the mappings. So check this out. The file system stuff has changed tremendously. So if you were doing something with a file system and you're not sure how to do it now in Zig 016, check these release notes, type in the thing that you're trying to do, and then find the new version on the right. All networking APIs are migrated to IO. Evented does not yet implement networking. So just keep in mind that IO evented does not implement networking. So if you're doing networking, you need IO threaded for now, or hand roll your own implementation that does support it. IONet currently lacks a way to do non-IP networking. So if you're doing networking without IPs, you don't have a way to do that. Just something to be aware of. I don't know how many people that will directly affect, but maybe some. Some examples of changing processes. So spawning a child process is no longer standard process child init. It's standard process spawn, and then you give it an IO interface, and then your args, standard in, standard out, standard error. Needing to capture its output is standard process run. Replacing the current process image is standard process replace now. File memory map. The pointer contents are defined to only be synchronized after explicit sync points, making it legal to have a fallback implementation based on file operations while still supporting a handful of use cases for memory mapping. Furthermore, it makes it legal for evented IO implementations to use evented file IO for the sync points rather than memory mapping. Technically, this is a breaking change because the positional file reading and writing error sets are more constrained. Also, on WASI, you now get error is dir correctly instead of error not open for reading. POSIX and OS Windows removals. So some of these functions were at an awkward medium level abstraction and have thus been removed. Therefore, if you were using any functions removed from those namespaces, you must now choose a direction. So you can go higher and use standard IO, or go lower and use standard POSIX system directly. More removals are planned. Be aware of that. Heap ArenaAllocator becomes thread safe and lock free. That's really cool. I was unaware of this. So lock free and thread safe plays better with the standard IO integration. Yep, totally does. And libc. By avoiding locks, we avoid needing sync primitives and therefore avoid needing an IO instance, and also allow the allocator to be used as the backing allocator for an IO instance. Yeah, that's huge. That is really, really nice. So if you're doing IO stuff, you can always, like if you want to make sure that you're cleaning up after yourself, and it makes sense to do so in this case, you might want to actually allocate resources and keep them long-lived, but you could essentially use an arena for your IO interface, like your backing IO implementation. And then like maybe a good example would be if you're making fire and forget network requests, you could pass in an ArenaAllocator to the IO instance. And then when you do your IO operation and it succeeds or fails even, you could just free the memory in the arena and then it'll clean up everything after itself. Could be an option worth pursuing. I've not done that with the new IO interface with an ArenaAllocator, so don't take my word for it that that'll clean up everything. I think it should, and I don't think you'd have any memory leaks, but you know, always double check yourself. Okay, comparable performance where only being accessed by a single thread and a slight speed up compared to the previous when there were about 7 threads performing operations on it concurrently. Cool. Same thing is planned for heap debug allocator. Love to see it. The thread safe allocator has been removed. Basically, this was generally inefficient, and every allocator in which thread safety is desired can just be adjusted to be lock free and avoid slow blocking mutexes altogether, or at least in some of the hot paths. This is an anti-pattern. This is a situation where tight coupling is called for. Okay, sure. Deflate compression, simplify decompression. So we added deflate compression implemented from scratch, history windows kept in the writer's buffer for matching, and a chained hash table is used to find matches. Tokens are accumulated until a threshold is reached and then outputted as a block. So more compression type stuff. We also have some zlib comparisons. So zlib achieves a 1% better compression ratio at the default compression level and a 0.77% better at the best compression level. It seems that zlib selects slightly different matches. However, the total matched bytes is less. In the future, it would be nice to figure this out and be on par with zlib. So essentially, we are getting compression changes that make us almost as good as zlib, with the goal in the future being on par. Benchmarks if you care. Expanded target support for segfault handling and unwinding. So on every target that sees real use with Zig, and probably even a few that don't, we now have working stack traces on crashes when using debug and when using debug allocator. Heck yes, I think this is huge. Additionally, inline callers are now resolved from debug info when printing stack traces on Windows. If the debug info is ambiguous, all candidate callers are printed. Support for resolving inline traces from Dwarf is also planned. Windows was prioritized as PDB initially associates return addresses with the outermost inline caller, leading to a particularly poor debugging experience if the other callers aren't resolved. Makes sense. Part of a larger effort to make making video games than Zig better or easier. Removal of uContextT and related type functions. So this type was useful for doing two things: doing non-local control flow with uContextH functions and inspecting machine state in a signal handler. The first use case is not one we support. We no longer expose bindings to those functions in the standard library. They're also deprecated in POSIX and as a result, not available in Musel. The second case is valid, but is very poorly served by the standard library, as evidenced by changes to this really long function scope. In this release, users will be better served rolling their own uContextT and especially mContextT types which fit their specific situation. Fair enough. Debug info has been reworked. Zig 0.16.0 reworks many standard library APIs related to debug information, and in particular stack traces. The motivation behind the changes was allowing fast stack tracing without needing to check every stack frame for invalid memory addresses, without introducing potential crashes in cases where frame pointers are unavailable, such as libc compiled with f-omit frame pointer. This is a surprisingly complex problem. Solving it requires unwind information, which is encoded in different ways on different targets. I don't remember, this wasn't Zig related, but I watched a really good YouTube talk on essentially unwinding. It was, I don't remember who it was by, but if you get the chance, I'll try to find it and I'll link it somehow in some way, shape, or form, at least in the description, if not somehow in like a bubble or something up here on YouTube. But it was building your own debugger and talking about the steps that are involved in doing so and unwinding. And it's just, this is such a wild problem. If this sounds interesting to you, highly recommend checking out that video as well. And I'll try to find a link for it, so I don't just say, go find this random video that I can't think of the name of. The Zig standard library was already supported using unwind information, but the support was buggy and incomplete and offered poor performance. The standard library will always use a safe stack unwinding by default if it is available, and the performance impact compared with a naive frame pointer unwinding is usually acceptable. The interface for printing a stack trace is standard debug write stack trace. So if you have a stack trace and you want to print one, you can use standard debug write stack trace. You can also use dump stack trace, which writes to standard error rather than accepting a standard IO terminal. To capture the current call stack into a standard built-in stack trace value, use standard debug capture current stack trace, which also accepts some options to control the stack trace collection behavior. So essentially what you can do now is you can use standard debug capture current stack trace to get you a stack trace. You can pass some stuff into it to change what you are and aren't capturing to some extent. And then you can do standard debug write stack trace or standard debug dump stack trace to actually throw a stack trace. This is really, really nice. I can see where I would want to use this, because I have some stuff where I start returning an error value and that error propagates up the stack. And I feel like providing more information about the stack trace in debug builds at least would help me make sure that I'm able to actually quickly identify where things are failing. Most of these functions have already existed in previous versions of Zig, albeit with different signatures, but there were also several more in the past which have now been consolidated. Here's the API if you're using one of the remove functions. You can see those mappings there. Inter-process progress reporting for Windows. Standard progress now supports reporting information from child processes on Windows. Cool. Windows networking without WS232 DLL. Networking API in Windows now implemented via direct AFD access. Fixes a handful of bugs, makes cancellation of batch work properly, and avoids performance pitfalls that exist in WS232 DLL's implementation of networking, such as maintaining an entirely unnecessary hash table for side data attached to socket handles that requires allocation and synchronization, rather than simply passing socket mode and protocol to the accept function. Completed the migration of NTDLL. I don't know what this is. All standard library functions on Windows are now implemented based on calls to the lowest level stable syscall API. The remaining extern functions in the standard library, which make calls to Windows DLLs, are mostly crypto related and kernel. Okay, Juicy Main. Yeah, this video is going on way longer than I thought it would. I have a video on Juicy Main. I will also link that in the description and in a bubble, hopefully right here. Check it out. It's cool. The short and sweet is we have this new main method signature that we refer to as Juicy Main. And essentially, you can get stuff by asking for it. So, for example, if we ask for a init, we can either ask for a init or we can ask for a init minimal. Minimal is included in a init. So if we ask for a init, we get minimal, which we'll talk about here in a second. We get an ArenaAllocator. We get an allocator, default selected general purpose allocator for temporary heap allocations. Debug mode will set up leak checking if possible. We also get an IO allocator. Also worth mentioning, the ArenaAllocator is cleaned up automatically on exit too, and both are thread safe, the Arena and the GPA. So we get an IO implementation, a default one, and again in Zig 016 as of right now, that is the threaded implementation. We get environment variables that are initialized with the GPA. These are not thread safe, just be aware of that. But if you want to read your environment variables, you have access to those now. And then you have pre-opens, which are named files that have been provided by the parent process. This is mainly used for WASI, but can be useful on other systems to mimic the behavior with respect to standard I/O. And then minimal itself gives you the environment variables and the command line args. So essentially, you can ask if you only want the environment variables and the command line args. Maybe you're not doing anything with allocations or I/O. You can just ask for a minimal. So in this case, you would say, give me an init, and that init is a standard process init.minimal. Or if you want all of these things, you can say, give me a standard process init. Unless they've changed this, my understanding as well is that if you don't specify anything, you won't get any of these. Like there's essentially, the compiler won't inject these for you, and there's no additional overhead. Okay, so you can kind of see how that's used here. So you can get the GPA from init, you can get the IO from init. They're creating right here, destroying right here, using that IO that is provided on the init to do some streaming writing, and then getting the ArenaAllocator and converting, getting the args and then putting those into the ArenaAllocator via a slice. Man, this is just really nice. Like if you look at this and you think about all of the things that you would need to do. So getting a GPA is going to be a couple lines of code. Getting an IO implementation is going to be a couple lines of code. Getting, what else do you get? Args can actually be several lines of code. Environment variables, several lines of code. It's just all bundled in now. And realistically, like if you need to defer from the way that this stuff is created for you, you can. But the fact that more times than not, people can just get this stuff out of the box and run with it is so nice. Yeah, so there's an example of using minimal, which is only argv in the environment available in raw form. And then if you have it missing, you don't get access to any of this stuff. And specifically, I don't think you can access CLI arguments or environment variables. So if you were accessing these globally, that doesn't work anymore. So if you were trying to get the environment variables globally, no more. You have to use at least minimal or init. Literally right down here. Environment variable and process arguments become non-global. So I just mentioned that. That's exactly what it sounds like on the can. Essentially, if you are reading these from standard OS Environ, you can no longer do that. And if you need them, you need to get them in the process init minimal or process init. This is a good change. It took me a minute. I was a little frustrated with this at first, mostly because I was using this foot gun. And I was doing things where I was referring to the global environ, and it was not a great experience. So yeah, this is much better. and simpler too, right? And like managing all of that stuff in one place instead of having a bunch of things accessing it globally is I feel it's better. Hopefully you do too. So example of accessing environment variables. So you can see init. We can get the environ map, call keys, call values, and then we can iterate through them like so. And then if you wanted to do it with minimal, you can see kind of what that looks like here. So because we're using minimal and not the normal init, we have to come up with our own allocators. So they do that right here to have an ArenaAllocator to work with. So we're checking that if the environment contains home, and checking if something is unempty, checking if it contains a constant, checking if it contains another constant here, getting like the home value from POSIX, getting a value from the environment, so specifically like getting the editor value that exists, because we're able to check that up here, and then creating an environment map with that ArenaAllocator. And then this is what we were doing right up here. So if you're ultimately going to just do this anyways, you probably should just take in the full init and not the minimal. I know that, again, that also gives you an IO implementation that you may not need. So, your mileage may vary. Accessing CLI arguments, very, very similar. So you can see here, using minimal, you get your init, args, and then you can call iterate. This gives you an iterator for your args. And then if you wanted to slice it, you can create it to a slice as well. So init, minimal, args to slice, and then now you have a slice for those. Mem introduced cut functions, rename index of to find. So we introduced cut functions such as cut prefix, cut suffix, cut scalar, cut last, and cut last scalar. In standard mem, the concepts are find, which returns the index of a substring, POS, so position, starting index parameter, last, search from the end, linear, simple for loop rather than fancy algorithm, and scalar, which is a substring of a single element. Standard ArenaAllocator walk can be used to recursively walk a directory tree, but it does not support skipping certain directories along the way. To support that use case, standard ArenaAllocator walk selectively has been added, which requires opting in to recursing into each directory entry encountered. This design allows avoiding redundant open-close syscalls for directories that are skipped. Yeah, that's nice. A nice improvement there. FS path Windows paths. Some more Windows changes here. Now handles Windows paths correctly and consistently. This is actually really nice, right? So like I don't build on Windows, but that's not to say that I am not deploying on Windows. I'm not building something that I would like people to. I'm not building something that I want people to not use on Windows. Double negative there. A lot of times if I'm building something on Zig, I'm building it on my Linux machine that we're on right now, but I want people to use it on Mac and Windows as well, and other stuff too if they want to. So having, like, even as a non-Windows dev, this is still nice to see. FS path relative became pure. I did not realize it wasn't pure. Oh, no, that makes sense. Yeah, because they now require passing the current working directory path and optionally an environment map as inputs instead of internally querying the OS for that information. That makes sense. I also like that. I know that, just as an aside, that feels like it might be a little more work that you have to think about. And again, like the upgrade guide, a lot of times we see this in the upgrade guides too, where 1 or 2 lines of Zig become multiple lines of Zig. I think that's just staying true to its ethos of being an explicit language, and I think I'm probably here for it in the grand scheme of things. Sorry, I've been talking for like almost 2 hours straight now. So yeah, file stat, make access time optional. File systems generally find this value problematic to keep updated since it turns read-only file system access into file system mutations. Some systems report stale values, and some systems explicitly refuse to report this value. The latter case is now handled by null. Cool. ZFS has observed to not report atime from statx. Okay. Some changes if you're curious what that looks like. Pre-opens, if you're curious about that, I would suggest looking into it. It's a pretty limited target audience, I think, for me, because it's very WASI related. But you can also get them from Juicy Main via standard process init pre-opens. Atomic and temporary files. I'm going to skip this. If this is something that seems interesting to you because you're doing crypto related things, or you want to, yeah, if this is, we'll just go with that. If this is something that seems interesting to you, my suggestion would be to read through this. I'm not I can read this to you, I suppose, but as for like pointing out anything that I think is important and trying really hard to not say things that get me demonetized, I will skip this. Memory locking and protection API moved to process. So mmap and mprotect flags now have type safety. Love to see it. And you can see the change here is now .read and .write instead of the old-fashioned way. And then mlock, mlock2, and mlock all are now standard process lock memory. And you can see that there's an on fault true and lock memory all, current, and future. The current directory API has been renamed. So in Zig standard library, dir means open directory handle. Path represents a file system identifier string. And this function is better named after current path than current directory. Get and working are superfluous. So the upgrade guide, instead of get current working directory and get current working directory alloc, is standard process current path and standard process current path alloc. We're almost done. Migration to unmanaged containers. In the past, Zig standard library offered two variants of dynamically growing data structures. One with the allocator instances as a field of the struct, so managed, and one where it must be passed in on every method that needs it, unmanaged. You should be familiar with this if you migrated to Zig 0.15. Over time, Zig programmers realized that the variant without the allocator field is more versatile than the other one should be removed. With only one variant, we no longer need this vague word managed to distinguish them. In this release, several APIs took migratory steps. So you can read through this, but memory pool managed, unmanaged, memory pool align unmanaged, and memory pool extra unmanaged have been added. Priority DQ no longer has an allocator. Priority queue no longer has an allocator. Array hash map, auto array hash map, and string array hash map have been removed. Auto array hash map unmanaged has now become array hash map auto. String array hash map unmanaged has become array hash map string. Array hash map unmanaged, array hash map custom. That's the translation. Priority DQ. Changes follow DQ closely. Methods containing add have been renamed to push, and remove have been renamed to pop. Pop min or null and pop max or null have been merged into pop min and pop max respectively without any loss in functionality. And then default field values are initialized using an empty constant instead of the init method. So there's an upgrade guide here. The priority queue with default fields can be initialized using empty. Example of this right here. So you have a standard priority queue, and then you call .empty. If you wanted to do a max heap, you have the exact opposite right here, where I say the exact opposite. It's almost the exact same, actually, but the greater than function that is passed in, the function that is passed in is a greater than function as opposed to a less than function. Information on upgrading. Thread.Pool has been removed. Hopefully that was pretty obvious at this point, given how much we've talked about the new I/O interface. So yeah, it's been removed. Use standard I/O instead. Uses of standard Thread.Pool spawn WG, so spawn wait group, should be likely be replaced with calls to standard I/O async or standard I/O group async. Though note that this assumes the task does not need to synchronize with the caller. So in other words, it assumes the new task is asynchronous with the caller. For instance, one migration might look like this. Yeah, I'll let you read through the migrations if you want. What else? Removing the built-in subsystem. So the subsystem detection was flaky and often incorrect and was not actually needed by the compiler or the standard library. The actual subsystem won't be known until at link time. That makes sense. So it doesn't make sense to try to determine it at compile time. This is a breaking change, but it is unlikely many users were using it in the first place. If your code absolutely needs to know the subsystem, there are ways to determine it at runtime. Move target subsystem to Zig subsystem and update the fields. So standard Zig is where options like sanitize C and L2 mode reside. So it is an appropriate place. Standard target subsystem remains as a deprecated alias, and the old field names remain as deprecated declarations to avoid breaking. So there's some information on that. I/O, delete generic reader, any reader, and fixed buffer stream. Migration guide, standard I/O with a lowercase I becomes standard I/O with an uppercase I. And then you can see how the rest of these migrate as well. Examples of doing the migrations as well. FS GetAppDir directory was removed. This API was a bit too opinionated for the Zig standard library. Applications should contain this logic instead. Users may consider third-party package known folders as an alternative. I'm a little bummed by this. I'm actually using this in one of my projects, and I'm going to have to change this now. Standard I/O writer allocating alignment fields. This API now has a new field, which is the alignment. This is a runtime known alignment value. The Allocator API supports this if you're using the raw function variants. Directory read file alloc has changed, so you can see how this is used. You pass in that limit difference. If it's reached, it also returns an error. Same thing here with a read to end alloc. So there's a limited that you can pass in, and it will return an error. Some changes to crypto. I'm going to skim through these. Changes to the build system, including this one, which is kind of important, which is the ability to override packages locally. So there's a new Zig build flag called fork, and this is a project override option. So the path provided contains a build zigzon file, which contains name and fingerprint fields. Anytime the dependency tree would resolve to a package with matching name and fingerprint, it resolves the override instead across the entire tree, completely ignoring version. This resolves before the package is potentially fetched, so if you find yourself without internet, forgot to fetch, but you have a Git repository lying around, you're one CLI flag from being away from being unblocked. This is a neat example, but I also think potentially a better example is that these forks allow you to specify overrides. So if someone has something and you need to mock it for testing or something similar, you could provide a stub implementation of their library so it doesn't necessarily do, well, actually, now that I'm thinking about that, if they're taking in an I/O interface, you should just be able to provide an I/O implementation that doesn't actually do the calls. It doesn't actually run the networked calls, for example, if you're worried about network requests and CI. So yeah, I don't know. Maybe this is interesting. Maybe this is the main use case for this. Or potentially patching something too, right? So if there's an issue with something and you want to patch it locally and the team that's building that package says, we're working on it, we'll get to it. Please stop submitting pull requests to fix this because X, Y, and Z. Maybe we need to think about something that you aren't thinking about because of security implications or something like that. I don't know. But you want to be unblocked. You could do an override here to unblock yourself. Fetch packages into a project local directory. So instead of them being fetched into your Zig cache, package dependencies are now fetched into a Zig package directory relative to the build root. Users are generally encouraged to not commit these files to source control, but however, it is understood that some will choose to do so for convenience. After a package is fetched, the filters are applied in order to delete files not a part of the hash, and then the package is recompressed into a canonical global Zig cache tar in order to avoid network next time the same package is needed. Motivation is to make it easier to tinker. Go ahead and edit those files, see what happens, swap out your package directory with the git clone, grep your dependencies all together. Yeah, it makes sense. Unit test timeout, so you can now specify a timeout to apply to all individual Zig unit tests using the test timeout flag in Zig build. So you can specify a timeout value, which the build system will forcibly terminate the current unit test by killing and restarting the test process and move on to the next. So if you have long-running tests and they shouldn't be long-running, that's an indication that something is wrong. Maybe you want to use a test timeout and just go ahead and kill that test if it's taking too long, because again, that's an indication that something is wrong. It can also be useful to just detect slow tests or tests that are failing to terminate. Tests that are, okay, this is important. Timeouts are specified in real time rather than CPU time. So on a system under heavy load, scheduler stress could cause unexpected timeouts. There's a new error style CLI flag of Zig build, which allows customizing how error messages from build systems are written to standard error. This default style, verbose, will print the full context, including relevant step dependency tree showing why this step is being built and failed commands where applicable. Alternatively, the minimal style can be specified to omit these pieces in favor of simply printing the failed step name and its error message. Okay. Multi-line error flag in Zig build controls how the build system prints errors which span multiple lines. So you can choose to indent, which is the new default, new line, and none. So this is the indenting. This would be the new line, and then this would be the none. Small thing, nice to have. Actually pretty happy with the default, to be honest. Temporary file API, so the remove_dir step is gone with no replacement. This step had no valid purpose. Mutating source files, that should be done via update source file step. Deleting temporary directories, that required creating the temp directories in the configure phase, which is broken. Deleting cached artifacts, that's going to cause problems. Similarly, build make temp path function is gone. This was used to create a temporary path in the configure place, which again is the wrong place to do it. Instead, the write file step has been updated with more functionality. Temp mode. In this mode, the directory will be placed inside temp rather than O, and caching will be skipped. During the make phase, the step will always do the same file system operations, and on successful build completion, the directory will be deleted along with other temp directories. The directory is therefore eligible to be used for mutations by other steps. Build.addTemp files is introduced to initialize a write file step with this mode. Yeah, this is nice. This is really nice, being able to have a clear-cut way to handle temp files as part of the build process. Mutate mode, these operations will not be performed against freshly created directory, but instead act against a temporary directory. Makes sense. We talked about C-translate and the compiler and how, actually this is different, but translate C is now based on AROCC, A-R-O-C-C, Aroc, I'm not sure how to pronounce that, and translate C instead of lib clang. Goodbye and good riddance to 5,940 lines of our remaining C++ code in the compiler source tree, with 3,763 remaining. The implementation is compiled lazily from source. In the future, Zig will drop the C import language built in, but now it remains backed by Arrow instead of Clang. This is neat. I don't know how many people this will probably directly affect people. I don't really know how many people care too much about how translate C is being handled. But yeah, this is technically a non-breaking change, while breakage is likely due to one C compiler being swapped out for another. If it occurs, it is a bug rather than a feature, so cross your fingers when you upgrade and report a bug if something breaks. Information on the LLVM backend, some of the work that has been done there, faster compilation in some cases, decrease in LLVM bytecode, yeah, just general improvements. Reworking the bival syntax lowering. So with the self-hosted compiler, there was an early experiment to attempt to slightly reduce the number of intermediate instructions emitted in the pipeline by lowering expressions with bival semantics. The experiment was a failure because it led to the following issues. This is I don't know if this is important. It's important to me. I like that the team called out that they had a failure. I think it is a nice reminder that like even really impactful large projects can have failures. And it also shows that, hey, if you were curious about this, like this is the outcome. The experiment was a failure and we decided not to do it. Here's the reason why. Yeah, just really nice to see. Reworked type resolution. I think we've talked a little bit about this already, but the compiler has been reworked to change how it handles type resolution internally. It's essentially to simplify the process of writing the Zig language specification and to resolve a huge number of compiler bugs, in particular related to incremental compilation. You can read more about that here, but I think we've covered quite a bit of it already at this point. Incremental compilation is a feature of the Zig compiler which allows it to only compile code which has been modified since the previous build. Allowing it to be built in milliseconds instead of seconds or minutes. In Zig 0.16.0, support for this feature has improved significantly. So there's some of the information about how this has improved. I have to imagine most people will just see the gains and not really need anything to change here. So I'll skim through this. But essentially, things have been faster by avoiding overanalysis. Incremental compilation no longer triggers the dependency loop compile errors, which do not occur in non-incremental builds. So there was a scenario where if you were doing incremental builds, you could find yourself in a dependency loop that wouldn't be there if it was non-incremental, which, not great. When using a self-hosted backend targeting ELF, the new ELF linker is now enabled by default. And then general stability has been greatly improved. Yeah. Outside of this, x86 has had some bugs fixed. The Arch64 backend is still a work in progress. WebAssembly backend is passing 92% of behavior tests, which is actually really good. Didn't realize it was so far along. And then generating import libraries from def files without the LLVM. If you want to learn more about that, that would be here. There's a new ELF linker. It can be used with -f new linker in the CLI, or by setting exe use new linker true in the build script. Fuzzer. So the array const u8 parameter of fuzz tests have been replaced with standard testing Smith. This new interface is used to generate values from the fuzzer. It contains the following methods. So value, any type, EOS as end of stream markers, provides the additional guarantee that true will eventually be returned, bytes for filling a byte array, slice for filling parts of a buffer and providing the length. Values can be given a probability of being selected with weights. In an empty slice of weights, every value has a weight of 0 and will not be selected. Weights can only be used with types fitting in 64 bits. Each base method has corresponding ones that accept weights. So there's baseline weights that provide a set of weights containing every possible value of type. Essentially what we're getting here is just more control over fuzzing. And you can see what that upgrade looks like here. So instead of taking in a slice of const u8, we take in a pointer to standard testing Smith. And then here we're using Smith EOS weighted simple, 7 and 1. To get an EOS weight. Oh, okay, sorry. We're using this to control the weights, and then we're getting a value from Smith. Okay, that makes more sense. When providing multiple tests, Fuzzer now switches between them and prioritizes the most effective and interesting ones. Over time, already explored tests will become barely run compared to tests yielding new inputs. Information on crash dumps, bug fixes, numerous bug fixes found with the help of AST Smith. This release has known bugs, miscompilations, and regressions. You can find them here. Definitely file things as they come up. Information on some tool changes, trying to see if there's anything particularly interesting. Key things here, the 017 release cycle is expected to be short, aiming mainly to upgrade LLVM 22 and finish separating the make process from the configure process. This is nice. This is pleasant to see because we've been waiting for 8 months, I think, on Zig 016. I think arguably longer at that point, but I think from 015.2 to 016, it's been about 8 months. I could be wrong on that. So a shorter release cycle will be a pleasant change of pace. After that, major initiatives will be completing and stabilizing the language, completing the Arch64 backend, enhancing linker implementations, eliminating dependency on LLD, and supporting incremental compilation, enhancing the integrated fuzzer to be competitive with AFL and other state-of-the-art fuzzers, and transitioning from a library dependency on LLVM to a process dependency on Clang. Contributors, so thank you to everyone who contributed. I'll say that as well, as not a representative of the Zig team, but I am grateful for your work. It helps me make my job easier doing Zig stuff, so I appreciate it. And then people who sponsor as well. Okay, I think that's it. I'm just circling back all the way to the top, trying to find exactly what I was looking for. Just calling out again some things that I'm really excited for. The improvements to switch and the new options for prongs, especially with 014's labeled switch. Just being able to get more creative with switches, I think, will be a very powerful thing. The Juicy main, I'm excited about. I've already put a video out on that. Check it out if you want to learn more. And then the I/O as an interface, I'm excited for as well. Outside of that, there was one more thing that really caught my attention that I was excited for, and I've already forgotten what it was. Yeah, not seeing it off the top of my head. Just scanning through these. But yeah, I'd be curious, what are you excited about? If you want to let me know in the comments below or join our Discord and chat about the new release notes. We've had a couple people talking about them already, so I would love to hear your thoughts as well. I think that's it. So I know this was a long one. Thank you so much for sticking with me and walking through these release notes. I hope you're very excited about 016 as I am, and I will probably put out some upgrade videos of me just going through the hard parts of upgrading a couple of my libraries and packages, projects as well, including Dust, which will probably be the biggest one, the Dust media server, to Zig 016. And yeah, keep an eye out for those if that's something you're interested in, and we can sort through 016 together. Thank you so much and have a great day.